So how can we determine, given a data set, how can we determine whether or not a given value qualifies as being unusual? Either it's unusually large or unusually small. Well, first, in statistics, we have a word for unusual. Right? The word we use for that is an outlier. And there are different ways you can do this, right? We're going to talk about two of the more common ones here. First, we're going to talk about how to determine if something is an outlier using z-scores, and then we're going to talk about how to do it by looking at the interquartile range. So I've got a data set here. We've worked with this data set before. It's a collection of test scores. And I've got the mean and the standard deviation. I've already calculated them. So what I want to do here is I want to determine what are the upper and lower bounds for outliers, right? What is the number where past which, above which, a data value will be considered unusual, and what is the value below which a data value would be considered unusual? Well, a common method for doing this using z-scores is to look at the values 2 standard deviations above the mean and 2 standard deviations below the mean. Any numbers outside of that range would be considered an outlier. All right, so let's calculate them. First, I'm going to do mu plus 2 sigma. That'll be my upper bound. And then over here, I'm going to do mu minus 2 sigma. That'll be my lower bound. So let's put numbers in here. This is 0.717 minus 2 times 0.151. And you go to your calculator. This is 0.415. I'm going to do the same thing over here, but with plus. 0.717 plus 2 times 0.151. And that is 0.416. So anything, sorry, I copied the same number again, didn't I? This is 1.018. There we go. So that's my upper bound and my lower bound. So do I have any numbers that are greater than 1.018? Well, I don't. Right? My maximum one, my biggest value is, whoops, sorry, the numbers aren't sorted, are they? Got to be careful. The biggest number is 0.91, and that is less than my upper limit. So I don't have any outliers on the upper end of the data. Now, how about on the lower end? Do I have any numbers that are less than 0.415? And in this case, I do. Right? I've got 0.4 here. That is less than my lower limit, so I would consider that to be an outlier using my 2 standard deviation rule. Okay, so there's another way to do this. It's based on the interquartile range. We talked about that when we're talking about percentiles. And what I've done here, we've got this data set again, and I went ahead. I calculated the 2 quartiles, right? Q2 and Q3. So the interquartile range, that is the difference of the two. So I'm going to do 0.83 minus 0.63, and I get 0.20. And what I'm going to do here, this is actually very similar to what we did with standard deviations and z-scores. Right? When I was talking about standard deviations, I said, okay, plus or minus 2 standard deviations above the mean. Well, what I'm going to do here is I'm going to do plus or minus 1.5 times the interquartile range above and below the median. Right? So the median of my data set is 0.74. So what I'm going to do is I'm going to do 0.74 minus 1.5 times the IQR. And I'm going to do 0.74 plus 1.5 times the IQR, right? And now it's going to your calculator, right? Put 0.2 in there for IQR, and you get 1.05, and you get 0.45. And now we ask the same questions. Are there numbers above 1.05? Well, no, there aren't. So there are no upper outliers. Are there numbers below 0.45? Well, yeah, there are. There's 3 of them, right? These 3 here, right? In fact, I didn't highlight it on the last slide, but 0.38 would also be considered an outlier using our plus or minus 2 standard deviation method. So there's our results. Here, using this method, we have 3 outliers. 0.43 kind of crept in with this method, where it didn't get included on the last one. So, which one is better? Well, this is all kind of arbitrary. How we define significantly outside the norm. Which one should you use it? It's a judgment call, right? You're going to look at your data. You're going to apply one of these methods, see what you get, and see if it looks reasonable. And then what you're doing when you're doing a full statistical analysis, you look at that outlier and you try to explain it. Right? You see a value that's kind of way out there. Why is it way out there? What happened? Is there a student? You're talking about test scores. Is there a student who is having some kind of outside of the class issue? If we're talking about experimental data, something in physics or engineering, for example, you got, well, maybe there was a problem with the machinery. Maybe the machinery wasn't properly calibrated before we did that one measurement. Or maybe there is just something really weird that happens. And you need to, design more experiments, do more research. Okay, so those are our 2 methods for determining outliers. Where are we going next? In the last lecture in this section, we're going to talk about something called a box plot. Right? What a box plot is, it kind of combines these 2 things we've been talking about. Right? It takes several of these measurements that we've been looking at, and it combines them all into one visual presentation. So in a sense, it's a visual summary of the numeric summaries.